Hi, everyone, and welcome back. Today, we will be going through assignment 6. Now, as fair warning, I'm hoping to start weaning you guys off of these video tutorials probably after spring break. So plan to get this one, probably assignment 7. Assignment 8 is going to be a review, so I am going to hope that you guys can do that on your own. But then we're going to try without them for a little bit, because at this point, you should have something of the hang of like how to do some of the basic stuff. You should have a feel for what it feels like to do the coding, what it looks like to do the coding. So just, pay attention to these videos because I am trying to put little helpers and tidbits that will hopefully carry you through the rest of the semester. So assignment 6, we'll be looking at measures of dispersion. And so as always, we start off in our local folder, and we're going to go ahead and open the most recent one that we did, which in this case was assignment 5. As an FYI, I recommend you always start, the word I'm looking for. You always start these things with like a fresh session, essentially. So sometimes the temptation, which can make perfect sense, the temptation is to just leave RStudio, the program, open all of the time. The problem is that it will sometimes, if you've already loaded data in here, they can sometimes start to conflict. Or if you've already loaded in libraries, you don't have to load them in again. And so you have to know what your environment's doing all the time. And this can lead to conflicts and errors and just kind of junk building up. And so my recommendation, whenever you're starting a new assignment, is to to close RStudio, the program, and then reopen it the way that I just showed you. So you see I was working on your assignment stuff. That, save. So as usual, file, new file, R markdown, assignment 7, Word, go. See, I was working on your other assignments. And get rid of this crap. Okay, so like I said, this exercise or this assignment is designed to teach you about measures of dispersion, variation ratio, range, interquartile range, variance, standard deviation. So I am assuming that you have read the requisite chapter and that essentially you remember how to do things from the prior assignments. So if you're unfamiliar with anything, chances are you need to go back to either the chapter or a previous assignment. Also make sure that you've listened to the lecture for this week. Oh wait, this is assignment 6. My bad. We can go ahead and just save this right now. D230214. Ducate, RAM 5305, assignment 06. Alrighty, so the first thing we're going to do is read in some data and determine some measures of dispersion. So we've already gone through a fair bit of part 1 already, which is just opening the or creating a new R markdown file and saving it. We need to load in some libraries. Make a second level header called part 1, assignment 1. As a note, and I might have mentioned this in a previous video, but make sure that there is a space between your 2 hashtags or your 3 hashtags and the name of your actual header. If you put them next to each other like this, this will not get recognized by Pandoc, which is doing the knitting for you, as a 3rd level header or 2nd level header. And so it will just show up as this instead of formatted as a header in your Word file. So load libraries, let's see. I need tidyverse haven here, sjmiss, sjplot, and summary tools. A little bit lazy, so I'm going to grab from here. Tidyverse haven here, sjmiss, sjplot, summary tools. I don't need GT, so I'll get rid of that. Okay. Read data into R. I'm going to read in the youth data. Oops. I've potentially already run these libraries, but let's go ahead and load them in. Once all of this junk has come out, has basically printed here, you can press these little double arrows to make them go away. You can click them again to show them. But sometimes it's nice to just not have that output there. Read SPSS, here, data sets, youth 0.sav. Go ahead and run that. It shows up in our environment. So it's about 1,200 kids with 23 variables for each of them. And we're going to view that data set. Youth. Screw it, we can put it in this code chunk. We're going to pipe view. Yeah. As an FYI, once you've run this command, go ahead and comment it out because it creates this really long, ugly output. And a lot of you ask if you should do that. And the answer is, yeah, go ahead and not have it print to your final knitted Word file. So this is our viewer. Go ahead and comment that out now. Okay, now we're going to make a frequency table. This V77 variable, which in this case is how wrong do friends think it is to steal? Okay. And so you should recognize this by now, but we're going to just make a simple frequency table. Remember, there are multiple ways to do this, but for our purposes, oops, there we go. We're going to do RQV77. And recall, I mentioned this elsewhere, but you can, if you've piped something, you can actually put the thing after the pipe on the next line. So functionally, this is going to be the same as this, but is not the same as this. Actual break. It doesn't, you can't start a line with a pipe, but you can end it. And so learning to do things this way makes your code easier to read in the long run, because sometimes you can have really long strings of pipes, essentially. Okay, so here's your frequency table. Now, based on this, you should be able to calculate the variation ratio of this variable and answer question 7 of assignment 6. So let's see. So assignment 7. So we're going to calculate the variation ratio by hand. So I will not show you how to do that. That is part of your job, including describing what it tells us. So instead, we're going to move on to part 2. Let's see. The next thing we're going to do, there's some exposition in here that you should read. So like, I'm not going to read all of this stuff to you, but you should absolutely read it yourself. Instead, we're going to do part 2, assignment 6.2, measure or calculate measures of dispersion for opinion. Note this is actually typed wrong. Fropinun, not fropinion. So opinion is spelled wrong in this. As an FYI, this is again where autocomplete is helpful. It's not going to help you for your general typing, but in your code, autocomplete will pick up on that typo and type it correctly and correctly. So we're doing propinion, delinquency, and certain. And create a new R chunk. Let's see, use data, pipe to FRQ. And note, see, it auto-completes for us. Just go ahead and do that. Let it help you. Cool, so now we have this big old output. I'm gonna make that go small for right now. Let's see. And then you're going to do this for your other variables. So what you should be doing is something like, I'd do a 4th level header, frequency table of, and then, et cetera, et cetera. And now the nice thing about these frequency tables is that they let you know what the mean, standard deviation, total, stuff like that is. And so you will basically use these frequency tables, very simple things, to be able to calculate, in this case, the range. So you should be able to either do this by hand or recall that R is a calculator. And so you can do the calculation in R. And then in terms of standard deviation, you should be able to calculate this by hand, but it actually gives you the standard deviation. The other thing you can do if you want just the standard deviation, SD is use data opinion, and that will give you mostly the same value. Rounds, it doesn't round it for you, so you can do the rounding yourself, but otherwise it's the same outcome. Let's see here. Note that these are calculating sample standard deviations, not population standard deviation. So remember the formula is ever so slightly different between the two. And so for some reason you want a population standard deviation, you have to do that either manually in R or by hand. Okay, so the next thing we're going to do is create a box plot. Basic box plot of opinion. And I've actually just given you the code for this. There's 2 different ways you can do box plots. You can do the base R ugly ones, so box plot, youth data, opinion, and just run that. Just gonna think. And it'll pop this out for you. Very simple bar graph or box plot. And so this is kind of nice if you're trying to do a whole bunch and you just want a super easy way to do it. But we can use our good old friend ggplot to make a prettier version. Box plot of opinion using ggplot. And remember, we can pipe youth data. Oh, crap. Yep. Downside of hotkeys is sometimes you forget them and press hotkeys for other things. So we're going to pipe to ggplot. Use our AES. function for opinion. And then remember, if we want to like chain these together, well, again, we can put this on a new line, but then we add a plus sign, which tells GG, which is specific to ggplot. You can't do this with just any function, but ggplot often is expecting you to chain a lot of different functions together. And so you can put this plus sign, which says, hey, look to the next line because I've got more stuff that I want to say. So in this case, we're going to do geom boxplot. And run this. And it's going to give us this whole thing, which arguably doesn't look on its own that much better than this whole thing. It's on the side, it's flipped sideways, which is potentially preferable. If it's not, hold on. Remember, you can go to your help files by typing a question mark and then the name of the function, and it will tell you like what some of the defaults and options are. So like when I see this, I go, I bet there's a way to flip that vertically. And so let's see. There might not be. Oh, because I did geom function. Geom boxplot. That's what I want. So orientation. I bet that's going to be it. Let's see. Scroll. Doesn't always work. Okay, so this turns out to be a bad example. I thought it would have a simple flip option, but that just goes to show you should always look into it. I do know that boxplot, the basic boxplot, I think does have that option. Yeah, so horizontal false. So we could have done boxplot and added an option for horizontal to be true. And then we'd also have a horizontal boxplot using the base function. So it's not in your assignment, just kind of how you dig through help files and follow intuitions and whatnot. Okay, that was a bit of an aside. Let's go back here. So you've got this basic still boxplot, but using ggplot, which means we can do some cool stuff to it, like adding some color. And so the way we do that is we can use the same code. And I'm going to be a little bit lazy and just copy paste this. And there are now options in geom boxplot, which we actually could have seen in our help files. Ggplot's complicated, where we can add fill colors. So in this case, we're going to do turquoise. If I can spell it. There we go. So here's a cool feature of R. Depending on how your settings are, it will actually preview the color if you've written a real color. So in this case, turquoise, color equals black, which is kind of nifty. That I believe, oh, they moved things around on me. Tools, global options. Probably under appearance, might be under code. I'm not going to fuss with it now because I'm going to make this even longer than it already is. But it is an option to turn on or off, whether or not it's previewing the colors for you. But now we can run this. Come on. We can see we have this lovely turquoisey color that we've filled the box plot with. And you can pick pretty much any color that's a real color. You can also look up hex code colors. So for instance, if there's like a specific, I don't know, can typically go, like if you just Google hex colors, like These are all, they're like six code colors. So it's like, let's say I like this dusky rose. I can copy this, add it here instead. Oops, has to be in quotes. You can see it showing up as this dusky color. Then I can run this code again, and now it's this cool dusky pink, which actually I like a lot better than the turquoise. Okay, so now you've got your box plot, got a jazzed up box plot. And so you should be able to do this with all of your variables. And that's really all part 3 is asking you to do. So to determine measures of dispersion for delinquency and certain variables. So that means you're going to create your frequency tables, you're going to make your box plots, and then let me get back to the assignment. Nope. Too many things up. Yes. You're going to use the outcomes to find the range for these other variables. You're then going to upload. You're going to save a PNG of your delinquency box plot. So you're going to do something similar to this. And then at the end, you're going to use ggSave and type in, what did I tell you to call it? You'll also add labels to this. So I'm going to do this with this for opinion one, but you should be doing this with the delinquency one in particular. So, generalize from here. But you can add labels by adding a labs function, and then calling title equals box plot of friend's opinion. And that'll put a title here. And then you can save this by doing ggSave here, and then Ducate delinquency box plot .png and save it as a PNG. JPEG would also work. And you can check to see if it worked by going to your folder, and ta-da, it pops up. And so you're going to upload the delinquency version of this. And once you've done all that, you should be able to answer all of these questions, including answering which variable has the most outliers based on the box plots you make. So you need to make all of the box plots. You're not necessarily answering questions about each and everything that you're creating in the assignment, but you are going to be uploading the final knitted Word file, and I will be looking for that. The very last thing I will say, because again, a lot of this is repetitive, is that I have noticed that for many of you, you've got a default setting set where you are reading in, where every time you open a new RStudio window, it's reading in like your past R data. I recommend you turn that off because that can confuse things. So this restore R data into workspace at startup, if this box is checked for you, uncheck it. And never save the workspace to our data on exit. It's not terrible to do, but reading in like old data can again sometimes clash with new stuff that you're doing, and it's better to just start fresh every time. History is pretty fine though, so always save history even when not saving our data. I typically do that. That's why you notice when my stuff popped up, like your next assignment popped up, this past one pops up, anything that I've been working on pops up. I don't really care about that. That's perfectly fine. But what you don't want is for like new data to be saved. So if you were to save the R data now, it would save this youth data stuff as well. And you don't necessarily want that if you're working on an assignment that's not using the youth data, because they might interfere somehow. Or if you've got libraries that conflict with one another, how they conflict depends on which one gets loaded in first, and it just gets messy. Like if that sounds confusing, that's all the more reason to not save your R data and try to start with a fresh session every time. So that should get you through assignment 6. Again, relatively easy. The frequency tables that you're creating are doing a lot of work here. And for other things, you're doing calculations by hand. But again, remember R is a glorified calculator. And so if you're going to use a calculator anyway, just go ahead and type it into R instead, and it'll do the same calculations that your calculator will do. So that's about it for this week, and I will see you next week for the Assignment 7 tutorial.